Well, let's go ahead and get started. Welcome to this community conversation. My name is Chris, and I'm going to be your community host for today. It is my great pleasure to welcome Jacob and Saul and special guest David today. We're going to be speaking about Dynamo. And by the way, I wanted to tell you guys, you stole my title, Going with the Flow. I used that in a tube and pipe class a few years ago. So
nice.
You got good taste. You got really good taste.
Great minds think alike, right?
Great minds think alike. So just a little bit about our program here, in case you're joining us for the very first time. Community Conversations is a group of live webinars where we have expert speakers from across the Autodesk community, both inside and outside of Autodesk, speaking on a variety of topics, from industry topics to product topics, how-tos, tips and tricks, just about anything you can think of. And sharing knowledge, making connections, and these are always hosted by somebody here at the Autodesk community team to help navigate the conversation and make sure that things are running smoothly. So quickly, our safe harbor statement that we always put up at the beginning of these, this is just basically saying that if during the course of this community conversation, we make any kind of forward-looking statements, that these are not to be made, not to be taken as promises or guarantees, and that if you're making any purchasing decisions, always look at the state that the product is in today, not based on anything that you might hear in this conversation. So there we go. And before we begin, we do want to let you know that you're muted at the moment, but you are free to join the conversation anytime that you want. We do want this to be interactive. You can use the Zoom reactions, the raise hand function, whatever you would like to do to get into the conversation. We'll be keeping an eye on the chat window for questions and comments. And you can also follow up later on this. We are recording the session. It's going to be posted on the event page, and it eventually will also make its way out onto YouTube. So on the event page, keep the conversation going afterward and add any questions or comments that you might have. Okay. All right, well, let's do some really quick introductions, and then I'll hand it over to our experts. You didn't come here to see me, but just so you know, my name is Chris. I am the Industry Community Manager for Design and Manufacturing. I was an Autodesk Expert Elite for 8 years. I almost made it to the 10-year anniversary, but instead I joined Autodesk and became a community manager. I came over to the dark side. I've been an Autodesk University speaker since 2014, and I've been active in the community forums since roughly 2010. So that's it for me. I'm going to hand it over to Jacob, Saul, and David. Gentlemen.
So I am Jacob Small. I am not a designated sports specialist anymore. I am actually a technical consultant. Apparently I missed that update.
Oops.
Yeah, happens. I describe myself as a Dynamo form junkie because you see me helping users on the Dynamo form at all hours of the day. Always willing to and really enjoy getting to see all the cool stuff that customers are up to and helping people achieve some really cool workflows. Currently based out of Boston, Mass, but heavy move coming up in the near future. So next time I'm on a conversation, we'll probably see a new location.
Nice, thanks, Jacob. So hello, everyone. My name is Saul. I'm a product manager for Dynamo, and I'm very excited here to kick off this series in Civil 3D, this 3-part series. I describe myself as a curious human being because I like everything, anything and everything and all of things. And I am based here in Boston, Massachusetts. Over to you, David.
Yeah, so thanks for hosting me. So I'm David, I'm based in Paris, but originally from Guatemala, so hence the background. And I'm in, I've joined Autodesk around 3 years ago, and I'm an implementation consultant, and I define myself as an innovation advocate because I enjoy trying new ways of doing things, right? And this is actually what get me into Dynamo, why I love it so much is because I absolutely hate to do repetitive tasks and things that add little value. I like to solve complex problems, so computational design is perfect for this, and I'm lucky to do this on my day-to-day job now. So.
Awesome. Well, welcome everybody. Thanks for joining us today. This is the Dynamo Office Hours series, which is hosted by Community Conversations. This is number 44 in the series. So there's 43 hours of awesome content out there. If you haven't seen it before, please go check it out on YouTube. There'll be some links getting posted into the chat at some point. And this is the first in the 3-part series on Civil 3D workflows specifically. So we did touch upon like the integration of Civil 3D previously in the series. This one's going to talk about going with the flow. Today, we're going to have where in the world is Dynamo coming up next, which is around GIS stuff, and then blocking it out around creating custom blocks, object blocks for the 3rd part. As every series, we have roughly a 20-minute presentation, plus or minus. We're then going to have a live demonstration, so cue the danger music. Things may or may not go according to plan. And we're going to have a Q&A session at the end. But please, as Chris mentioned, we really, really encourage you to interrupt us, to ask questions in the chat, to sort of be a part of this conversation, because it's not a presentation, ideally, for us. It's a conversation, and we really want to sort of have that two-way narrative going on between us and you today. So without further ado, I'm probably not going to talk very much from here on out, and Jacob and David are going to take it away and show really cool things with pipe networks and Civil 3D.
Awesome. Thanks, Sol. So before we get too far into the weeds, we need to cover some ground rules because, you know, talking about stuff in the context of Dynamo, we have to make sure we're all sort of using the same vocabulary. So right off the bat, we wanted to start with, well, what is a pipe network anyway? Effectively, there's 2 types of pipe networks available in Civil 3D. There's our regular pipe network called pipe network. It's basically gravity-fed piping. We're looking at stuff like drainage, stormwater, that sort of content. And then there's pressure pipes. Pressure pipes are basically the water distribution system, right? This uses the force of the pressure to get water to flow uphill, if you will. Today's focus is going to be entirely on regular pipe networks, right? We're not going to touch on the pressure pipe networks too much, a little bit in the vocab and sort of the upfront stuff. But in terms of the Dynamo interaction, because while they're very similar in many ways, so you can sort of get your way through once you understand regular pipe networks, they're different enough that if you try and do both at once, you're just going to confuse everybody. So we decided to kind of split it out and make somewhat of a clean break between the 2. All right, David, can you set some vocab for us?
Yeah, so this slide comes directly from the Civil 3D help, right? And I didn't study civil engineering in English, so I didn't know any of this vocabulary before joining and starting using Civil 3D, right? So we're gonna use some of these terms, so that is why it is so important. And let's start with the rim. So the rim is the top elevation of a manhole, or yeah, the top elevation of the structure, right? We have the frame that's support for the cover. And we have the cover that is the top access of to the manhole. So basically, we're gonna work here with the rim. We have the grate, that is also the top opening of a catch basin, and we have the sump and the sump depth. So the sump refers to the bottom area in the inside of a structure, and sump depth refers to distance from the bottom of the inside of the structure. So you can tell I'm reading this, right? We're basically going to use the sump to add some depth to the structures, and the rim to place them. So we can go to the pipe ones. The invert, so that's the elevation of the inside bottom of a pipe. It's also referred as flow line. We have the crown or the upward, that is the elevation of the inside top of a pipe. Then we have the pipe center line elevation, pretty self-explanatory. The cover or depth, it refers to the material between surface and the pipe, and we have the slope of the pipe. So here we're gonna work with the slope and inverts principally, but we have some nodes in Dynamo that we're gonna look also that lets you work with crowns, overts, the outer diameter of the pipes, and all that stuff.
All right, so now that we've got our vocabulary, all this data is in the computer, right? How do we get to it? Well, we're going to need some specialized tools, it winds up. Currently, there are not really many out-of-the-box sort of functions that you can use to work with pipe networks within Dynamo for Civil 3D. Some generic sort of civil object operations is pretty much the upper limit of that. And so as a result, we need to integrate a couple packages here. Primarily, sort of the absolute must if you want to do pipe network stuff, start with Civil 3D Toolkit. You can see that once installed will show up in the add-ins section of your Dynamo library and the newer builds down there under Autodesk, Civil 3D Toolkit, and then pipe networks. That's going to be kind of the primary focus. You want to make sure that you get those kind of set up and ready to go. The other package that's really useful for pipe networks is Camber. And so we're going to be touching on that one as well. It's a little bit easier to find inside of the package search because not many other people have referenced it. You don't have to worry about Camber space returning different results than Civil 3D Toolkit, one word, versus Civil space 3D space Toolkit. So yeah, one word when searching for Civil 3D Toolkit, and you should get the two options up there, one package that I produced for AU a few years back, and then the actual package you want from Paulo Serra, our colleague over in Autodesk Consulting. Oh, go, there we go.
Yeah. So I mentioned before structures and pipes, right? So pipe networks are made of these two components, the pipes and structures. And typically the pipes and structure are connected to each other, forming what we call a single pipe round or a pipe network. So the pipes can actually be linear or curved. We're gonna see that on the demo too. And on the structure side, we have what we like manholes, inlets, outlets, head walls, but we also have the null structure. So null structure basically allows to connect two pipes when there is not an actual physical structure. So yeah, we have this fake structure in the Civil 3D side, in the modeling side, and styles can be configured so that they are not shown.
All right, so David did touch on a key piece there in the larger set, and that's our parts. Parts come from our Civil 3D parts catalogs. Effectively, the idea here is to build it once and then use it repeatedly, or even better, just use the content that we distribute with the tool. Our parts catalog are organized by kind of the domain, meaning either pipes or structures. Then the type, for pipes, there's only one type. Pipe. For structures, it could be an inlet outlet, it could be a junction with frames, junction without frames. I think there might be even a couple others possibilities. But once you've got that sort of set up, you're going to choose your shape, right? Pipes have come in multiple different shapes. We've got our circular, egg-shaped, elliptical, rectangular. Structures come in a lot more shapes or based on the different type of part that you're working with. And then after we've got our part shape, we're going to go ahead and we're going to talk about our part family. Part families are going to be sort of the specific type of pipe that you're going to be working with or type of structure. So in one particular example, if I wanted to place a pipe, I'd start with my part domain of pipes, then I'd take my part type of pipe, then I would take my part shape. Well, let's say I wanted circular and I wanted PVC. So my part shape would be circular and my part family would be PVC. After that, we get into sort of selecting the size of the pipe. We'll talk a little bit more about that once we get a little bit further along in the session today. Note that beyond the out-of-the-box tools that are catalogs, there's also country kits that you can pull in, as well as customizing your own. So country kits basically enable working with localized standards. I put the link in there, but really you can just sort of search Civil 3D country kit, and it was my top hit on Google in several different attempts at finding it. So don't worry too much about trying to find that content, but we'll see if we can get it posted in the chat here in a few minutes. All right, after that, we've got our rule sets. Rules are basically set up to sort of help to ensure that our design functionalities our design is basically functional. There's really a few different primary uses. The first one is to automate the properties that we're using or properties of objects as they're sort of created, right? Like getting stuff to the right elevation, as well as determining connections, like how different pieces are going to connect to each other. David mentioned sort of the null structure stuff before, as well as identifying kind of non-compliance when you're sort of editing and manipulating and creating stuff as you go along. Rules are not very well exposed in the Civil 3D toolkit. Camber seems to be kind of the primary location for where you're going to want to go for those. So make sure you get that set up if you want to work with these. Great stuff you can do with that is sort of apply rule sets, find out which rule set has been applied to a given part, override the rule set, even remove rules from a rule set, which is pretty interesting as a topic.
Right. So when we work with pipe networks, we normally have two objects that we can reference and that will help us drive our design. So we have the reference surface. So traditionally we have a finished ground surface, right? A combination of the existing ground with the project. And so we have the finished design, and we use that to drive the elevations of structures of pipe also. And also applying the rules that Jacob just mentioned, right? The alignment, it provides the station of values for the pipe network parts. Okay, so also something important to mention is that the reference surface and the reference alignment information can then be leveraged in the properties of labels. So we can show some of that information in the pipe network labels. And one important notion to mention here is that when we work with pipe networks, we have a default reference surface for a network, so we can apply it whenever we want. However, if we already have pipes or structures, it will not affect what already exists. So we need to apply it to each individual part, and we will see that in the demo.
Cool. All right, now that we've sort of covered the basics, let's start talking about specifics to Dynamo. First thing that I always hear is, great, now I want to create a pipe, right? Or now I want to create a structure. It's pretty much everybody's always first task when they get involved here. And it winds up that you have to first make sure you've got your network set up. You can run into significant difficulty if you're trying to make your pipe network and create your pipes in the same run because of how sort of transactions are handled inside of Civil. So you want to keep an eye out for that as you go. In particular, it can be problematic with element binding. But once you've got your pipe network set up with that pipe network by name, I again recommend running those in separate graphs. Not necessarily a requirement, but there you have it. From there, we can start to add pipes to it. Now, interestingly enough, typically when we're trying to make objects, any element you make in Dynamo for Revit, it's going to be under that element type with the creation tools. You're not going to see that with pipes and structures inside a pipe network. And the reason being, they're basically a property of the object, the pipe network object itself. So you're really modifying the pipe network rather than creating new elements. Sort of the hierarchical structure. And this does align very well to the Civil 3D API, but it is a bit sort of counterintuitive. So you want to make sure that for creating your pipes and creating your structure, you're going to look under the pipe network area to find those. Now, you're going to need a few different inputs to get those both started. For the pipe network, or sorry, for the add pipe, you're going to need a pipe network followed by the part size that you want to use, again, which is a derivative of that family. And then the curve that you want to place the pipe at, and then the rules that you may or may not want to apply. After that, we get into our structure. Again, you're going to need that pipe network up front, the part size for the particular structure family, the point that you want to place it at, what the rotation value wants to be, and then what the rules are in terms of the application or not.
I want to complement a little bit what Jacob just said. You're going to see me struggle finding the correct node during the demo for sure, because I still sometimes I have some trouble finding where they are.
It really is kind of one of those things that's kind of totally makes sense if you're a Civil 3D API guru and you've been doing this for decades, but when you're just like, I'm a Dynamo user, it doesn't necessarily make sense. Why am I going to pipe network to create a pipe? I want to create a pipe. Why isn't that under pipe? I don't know. Anyway, on we go.
Yeah. So on the modification side, we have a lot of nodes that will allow you to change either the relationship of our pipes and structures, so this is the relationship to others. So set the reference surface, set the reference alignment, for example. We can actually modify also the size. So if you remember the table, we had the size, we can change the size. We can also swap parts. I didn't put it here, but yeah, it's something you can do sometimes. I think it's only on the camber side. Don't remember exactly, but yeah, we're gonna take a look a little bit more in Dynamo. The invert and slope for the pipes is something that you can also modify, and on the structure side, you can rotate them, change the location, and define the sum.
Cool. And now properties. Well, there are a lot of properties. If this slide didn't make that abundantly clear, that you can manage within pipes. Pretty much if it's something you want to know about it and it's something that's sort of stored in Civil, it has been exposed. I haven't found anything that hasn't yet, not to say it doesn't exist, but it's pretty much there. You can see I had to play around with my Dynamo window pretty significantly just to get these things to show all up. So instead of trying to go over all the things, I'm just going to hit some highlights for my personal favorites. Within pipe networks, get parts list, right, is a pretty big one to sort of figure out what it is that you're working with. Within structures, pulling the geometry, pulling the station, rim elevation, sump elevation, use those all the time in the engagements that I've had inside the pipes in pipe network area. For pipes, geometry is a really popular one that we use pretty much everywhere, but perhaps more importantly, and one that I work with probably even more, is the curve. Anytime you can work with a simpler shape, you want to, and curves are going to be simpler than geometries. It's not always possible. Let's say you were doing, I don't know, interference checking. Not saying we're going to do it, but maybe you wouldn't want to work with the curve because the curve is just a tiny little bit of where that pipe might be, the center, right? As opposed to the larger mass. So keep that in mind. We can also grab the outer diameter or width as well as the slope directly from the properties of pipes. And again, everything else you might want to know about a pipe is somewhere in this massive list, but don't worry too much about sort of trying to find it as you go.
Right, so I'm gonna talk about some exporting of either the pipe networks or the data, right? So we can export a lot of the data that we can get and all of the properties into CSV, Excel files, maybe, work on your bill of quantities. So something we can do with Dynamo. But also I wanted to talk about the LandXML EFCs and shape files, right? We're normally getting these pipe networks into either GIS or either into coordination spaces to do some clash check. So on Camber, you have some nodes to export on LandXML. So this is great. Just a heads up, it will export everything that can be exported. So you have alignments there. They will be also exported, right? On the IFC side, so to export IFC, a pipe network to IFC, you need to be on an isometric view. So you have some nodes on Archons that lets you go to a name view. So, what you could do here is create a name view before that's an isometric one. Then you can run an automation that lets you change into that name view and then send a command of IFC export, which is quite handy. And on the shape file side, I didn't find any nodes, so I haven't checked also the API. So I don't know if this is possible today. But yeah, maybe we'll get back to you on that side, on the GIS one.
Yeah, I think we might maybe touch on that at some point in the Where in the World session that'll be coming up next. But yeah, I have seen some creative ways to get to that content.
And just one thing I forgot to add here, in the forum that we have some examples of how to export objects into a new DWG. So you can actually use that if you want to export to LandXML afterwards.
Cool. All right. Next up is in Dynamo Analysis. So what can we learn quickly, right? And now this is really important because a lot of times when we're working with pipes, it's not just about automating the decisions that have already been made, right? Dynamo, it's great as an automation tool, but it's even better as a design tool, right? So it's important that we sort of understand what we can and can't do. So some tools that I've seen people develop and have done for sort of quick analysis, does this design work? Stuff like interference checking, right? We can check any geometry that we can gather against other geometry. Clearance checking, not just interference, but does this gas pipe have enough clearance to the water pipe or whatever else you might have, where these two pieces have to be sort of separate from each other. Slope automation and validation, right? You can do sort of sequential elevations by length in terms of sort of slope formulas and stuff like that, or by taking the length and multiplying by the slope formula. The asterisks in my notes there caught me up. All right. Basically, what that will allow you to do is you can sort of generatively create the start points of all your pipes to sort of minimize your excavation, which can be pretty cool and a great cost saving tool. After that, we've got our network optimization, right? This is something that I haven't done directly in Civil 3D yet. Would love it if it came around, but I have done it in sort of the building space where basically we know all the different nodes we have to connect, right? We've got this larger possible network of all the connections. What's the right way to route all this stuff so I have to buy the least amount of expensive pipe or keep stuff to the most consistent size or whatever it may be? So I've got an example of how a graph like that might work. Again, this is on the building side, utilizes the initial data set from Topologic, which is a great package. Maybe we'll do a session on that someday in the future, but effectively what it is it says, hey, take my initial nodes, that's that point, our start and end or end, start at the green, end at the red, and all the connections in between, what's the best way to connect these? And we can connect these either by shortest overall path, where the pipe sort of has to go uphill. Probably not great for gravity pipes, right? Water doesn't typically like to flow upwards unless we've got bigger issues to deal with. And so therefore, we probably don't want to do that. And that's why instead of the shortest path, we would look at that weighted path, which would be the other way, all the way around through. So great tools, and you can do a lot of amazing stuff with them once you get the data out of Civil into Dynamo, and then we can start to create the pipes and set those properties based on what that end result wants to be once we've made that decision in the context of Dynamo and Generative.
Sorry, I don't know why I muted myself. So yeah, we have some limitations and differences that can arise. Well, limitations that can arise when we are working with our scripts in Dynamo for Civil 3D. So everyone who has worked outside of the US with Civil 3D projects, I think, will have encountered the geometry scaling problem, where Dynamo is telling you to change into large or extra large. And I will say never do that. You're gonna lose data. So the GIF here is showing a nice trick around how to get around that warning using the function apply. So just to highlight here is just a warning, right? You can still continue doing your scripts, but can be problematic when you run it from the player and you have warnings arising there. But you also have the graphical rendering. So when you are really far from the origin, you will have some problems getting a good render and navigating. You can see it on the bottom right GIF or animation. And yeah, so here what you can do is switch all of the Dynamo proxies. So okay, the geometry inside of Dynamo, not the actual geometry in Civil 3D, right? You can switch it to the, translate it to the close to the origin. You will have a better rendering. You will be able to zoom in, zoom out, navigate, and then you can do all of the modifications that you want and send it back before getting all the data back into Civil 3D. And the other thing that we can encounter quite commonly, especially when working with pipe networks, is branching polylines. So you can see on the left side of the GIF, we have a branching polyline, right? It's a single element with branching. Yeah. So yeah, we will see it in the demo actually. And there are some workarounds. I'm not going to use any of the workarounds, but you will see them here in this animation.
Yeah, one note. So it is possible to change your geometry scaling to sort of get those warnings to go away. As Sol mentioned in Dynamo 2.17, you're going to do it from the workspace directly next to the canvas scrolling tools. However, don't do it in Civil 3D. The reason for that is when the data gets sort of processed over from your Civil workspace into the extra large coordinates geometry scaling or whatever else you may have, it will actually sort of devolve your geometry. You're going to lose data that's sort of really, really important within the larger context. So keep your geometry scaling at medium. I feel like I'm going to channel my inner Paulo Serra. Geometry scaling always at medium, never ever change it in the context of Civil, because it breaks stuff like when we read that pipe geometry in, instead of putting it at 1.4 meters or 2.5 feet, it's just going to round that off to 2 feet and things stop connecting, which isn't great. So there's lots of ways you can sort of get around that by transitioning geometry to the internal origin. Maybe worth a conversation in a future session.
Yeah, just to add to that briefly. So geometry scaling it's a problem that all software has. And so you'll notice that if you use Revit also has this issue. You can't make things too far away from the origin. Large numbers become very difficult for computers to handle, essentially. And so when you get into really large numbers and you're trying to draw relationships between things that are kilometers apart, it doesn't do so good. So there needs to be tricks that are played in the background of software to make that actually work. In Dynamo's case, we use geometry scaling. It's not the best tool. We definitely want to take another pass at this and look at this and try and improve in the future. But what it's essentially doing is mathematical operations to figure out what goes where. And as Jacob alluded to, part of that sometimes results in rounding errors, and those rounding errors can have dramatic effects on a design. So I would reiterate again in the case of Civil 3D, because this is where you hit the problem more often than something like Revit at a building scale. Please do stay in medium geometry scaling for now until we make a more holistic fix.
All right. So that's all our limitations and differences. Let's get into that live demo. David, are you booted up and ready to go?
Yeah.
All right. I'm going to stop share so you can take over. And we'll start to get into the cool stuff you got prepped.
So I'm going to say first that I'm not like Jacob, right? I'm coming prepared. So you can see my screen, right?
Yes.
Is the Dynamo forum one showing? Is that?
Yep.
Okay, cool. Right. So I actually came a little bit prepared. And when I was preparing the session, I went to the forum and searched for pipe network, see what were the problems there, if we could use that as an example, and actually found this old post that never got answered, where we're going to try to tackle that problem. But basically, you can see here, the user didn't knew how to get the pipes at the correct elevation. So we're gonna try to tackle that. And basically what we are doing is that we will have some polylines, and from there we're gonna construct our pipe network and then set it at the correct elevation using this 2.5 feet from the ground. So this is what I have here now in Civil 3D. I have some polylines here, for example, and I put them in layers starting with UT, so for utilities. So you see we have some curves here. There's another polyline here, UT01, also with some curve. And I have a branching one, so we can see what happens there. Right, so I'm gonna start with the demo now. And I have my cheat set on the side just to be sure what I want to do. So the first thing is I want to get my polylines, right? So I need to get my document. And most of your scripts in Dynamo for Civil 3D are going to start like this, right? Basically. And you need to get the model space, right? So I'm going to get that. I'm going to get the layers. So I'm going to filter using, and I don't know which one is a bit. Gonna go here. It's not this one, sorry. So I know on the backside on Dynamo, we're working on this, right? So on the searching capabilities. But
Yes, we are. Search is going to be started to work on about a month, and we're going to try and improve it. Well, we are going to improve it for sure. Make it much better.
Yeah. So this is what I was looking for, the layers, right? So I'm gonna filter the layer it starts with. So yeah, I know that all my layers where I have these utilities are start with the UT. Okay. So I'm gonna do this. And I don't know if we will have the time. I think we won't have the time to go through all of what I prepared, but I'm gonna share all of these scripts afterwards in the forum. So yeah, now I'm gonna get all the objects in this layer. So actually I had it here. So it's on the selection side. Sorry, all objects in layer. When you ask for the block, so it's the model space, right? And I'm gonna flatten this list because I know I'm gonna get that. And if I run here, okay, I have my 3 polylines there, right? So the next step will be to get the geometry. So there are nodes either in the out of the box in the Civil 3D toolkit or in Archons. I would recommend use either Archons or the Civil 3D toolkit because there are some problems with the OTB out of the box node to get the extension, the geometry, sorry. So I'm gonna use this one, extensions. So let's see what happens. Remember, I have this branching polyline, right? So I got a no for that one, right? So this is why we say branching polylines are a problem. So yeah, if you have those, you will not be able to work directly with them. You will need to do some workarounds, for example, exploding them, that kind of stuff. So I'm just gonna clean this and we're gonna pick it up from here. And then I want to get the curves. So I'm using the curves of the polyline to place my pipes. This is what I would be doing. So this is polycurve curves. Yeah. Oh, sorry, it's this one, right? So now I have the curves. I will use them to place the pipes. I will also want to get the vertices to place my structures, right? So for this, in the Archons package, we have some cool nodes, and it's actually here on the geometry polyline 2D. Sorry, I made this a little bit too small. Yeah, and the one I'm looking for is segments. Okay, so basically it gives me the curves. I could have used this. I just wanted to show like we can use different packages for different things, right? And I have on the geometry side then, so where is it? Geometry here. Sorry, it's here down below. So it can be a little bit confusing, but the polyline 2D segments, then I can get the endpoints. So basically, I'm gonna use the endpoints of my individual curves to place my structures and the curves to place my pipes. So normally I would also get the starting point. For the sake of time, I'm gonna skip this, and but I figured you get the gist here, right? So you can see here that we have already some curves and some points. So now we want to generate our pipe network. Okay, so to create pipe networks, we're gonna use the Civil 3D toolkit. In another example, I prepared only with nodes of Camber, so you can see also the difference of how to interact with them. I don't know if we're gonna get until there, but yeah, the pipe networks are here. So you can create a pipe network by name. Okay, so we need the current document. I had it all the way here. And then we can give a name. So I'm just gonna write it on a list. Normally I will do this programmatically also, like figure out some names to assist and everything. But yeah, for the sake of time, I'm just gonna write some names. So I'm gonna put UT1 and sorry, UT2. let's see what happens when I run this once. Gonna do this, and you have the prospector here in CL3D, so we can see exactly what is happening. I already have some networks. Gonna run, they got added. If I run again, you're gonna see afterwards when I continue, when I do some changes into the script, that will be the problem that Jacob talked about. So yeah, I will definitely advise to have this as a single script. I will continue now, just for the sake of time, and show you a trick on how we can get around this. So the next step is to actually define the parts that we're going to use to place our pipes and our structures, right? So for this, I have it's called pipe networks part list. Yeah. And it's asking me for the document. I actually gonna add another one just to be quicker. Not I have to scroll down all the way. So yeah, if I run this, you can see there's a parse list. There's the standard one. Okay, so something I didn't say before, I'm using one of the sample files of drawings that come with Civil 3D, right? So I only have one part list in this one. It's a standard one. Usually I will advise for you to know the part list and have strong naming convention of what you are going to look for. But yeah, right now we have that. So what we are going to do is that we are going to set the part list. Okay, so we have it here to our pipe network. Okay, and I'm actually gonna set this lacing to longest, right? Because we have one part list, about 2 networks. Okay, so I'm gonna run this from start. I think now we are going to have those problems that we said before. Not entirely sure. Yeah, I think.
Try clicking into civil and then just hit escape. I think it might. No.
Yeah, I have it. I think it all froze. But yeah, once we set the part list, then we will get, the part families, so the types that we're going to use, and the pipes and structure that we want to select from our part list, right? So that will be the next logical step. I think I will need to close Dynamo CL3D. So sorry for this.
No worries.
And how are we running time? Because if not, I can open the already created script and go through that one.
Trying to find my Zoom.
We've got 17 minutes left.
Yeah.
And this
Okay,
is the
so
danger
maybe
music piece. The
Yeah.
broken.
So yeah, I think we'll continue on the script that I already made, just to not redo this part, right?
Yep.
So yeah, sorry about that. CL3D is opening on my other window. In the meantime, if you have any questions. But yeah, this is exactly why Jacob said, do this in separate graphs, right?
Yeah, and actually, I would go a step further than that. In a perfect world, I wouldn't run a graph to make my pipe network. I'd have it in the template that I'm starting with, right? So that, just like in Revit, I've got my standard wall families loaded in. I'd want my standard pipe network already created and try and work in that context, rather than trying to have one graph build all the things at once. Work within your standards anytime you can.
Yeah. So yeah, I'm gonna open the graph that I had done. I'm gonna go through that one. Then we are gonna construct the other ones maybe. There's one that is really small one, so it'll be fun. So yeah, Dynamo is opening at the moment. I think my whole setup is not that quick, right?
Yeah. It's also slower over Zoom.
There it is. you're gonna see it's much more organized than what I was doing before.
Such is always the case. Add that, get the initial proof of concept working, and then start to go back and do your documentation.
Yeah, that's exactly it, right? So yeah, I said before, like you can generate the name of the pipe network programmatically. This is how I did it there, using repeating of elements and then adding, counting how many polylines I have. So this should work for 2 or 10 or hundreds of polylines if you don't have branching, right? So I was here, right? I set the part list. So yeah, longest lacing. Then we have on the Civil 3D toolkit, we have this node also of the part family. So yeah, it's, as I say, it's always quite tricky to find. I navigate a lot through the different categories, but yeah, this is the one, right? So I'm giving the part list, and we will have 2 types of families, the pipe ones and the structural one. So what I'm doing next is just getting the sizes and basically choosing the first one. So obviously I will not do it like this if I'm really designing a pipe network, right? I will put and choose which one. This is something that the user can have as an input on their script, right? So they can choose what type of pipe and what type of structure we are going to get, right? So this is the only thing I'm getting here is basically that. And I have also this node of list of repeated items because again, I'm working with multiple polylines, multiple pipe networks. So I need to have multiple pipe sizes and multiple structures. Right? Then we have these 2 nodes that Jacob highlighted on the theory side, right? Add pipe by curve and add structure by point. I would also say that you can apply rules if you have them in your standards, then here, right? So what else should I say? So you have the pipe network, the part size, and the curve as inputs. It's here you also have the point and the rotation for the structure. So this is why I'm using the vertices of the polylines, right, to place my structures. And you can also apply the rotation. So for example, if you're following an alignment or a corridor, right, and you're placing your manholes there, I will probably use the coordinate system offset also to, actually get it out from the baseline or from the future line to align the manhole to its correct position. Right? I'm not doing this now just for the sake of simplification. And one last thing, so maybe I'll just freeze something here and we can see it actually in Civil 3D. So I'm gonna run here. Yeah, didn't broke. Okay. So I have my pipe networks normally here. I'm gonna use Project Explorer. So I don't know if you know Project Explorer, but it's really handy to navigate Civil 3D and also in terms of pipe networks, it's really, really useful to visualize quickly without having profile views and all of that. But if I go to my pipes, a valid path is not being found. Why is that? It's because my pipes and my structures are not connected. So I use the lines to place my pipe. I use the curves to place my pipe. I use the points to place my structure, but they are actually not connected between each other. So this is really important when you are working with pipe networks in Dynamo, right? Here in Civil 2D, you do it graphically. In Dynamo, you will want to connect everything. So I'm gonna unfreeze that. And here what I was doing is basically just dropping, the first pipe because I don't have a starting structure, right? So if you remember, I'm using only the endpoints. So this is what I'm doing here. And then I'm just making sure. So this is a handy trick I learned from the forum, actually. I think it was Zachary, the creator of the Camber package, who used this convention of wait for pass through. But I'm just making sure that we have the pipes connected to the structure before I get the connected pipes. And this is only to verify everything is working, right? So the handy trick I mentioned before is about changing the name of your pipe network. So you can get, you can, how to say it? Sorry, I forgot my English a little bit right now, but if you want to avoid to crash Civil3D like I just did before, you can change the name and it's handy. It will work around the binding, right? So actually I'm gonna put something like demo.
Oh, this is, do you mean to be changing the layer that you're getting the data from, or do you mean to be changing the
yeah,
pipe
sorry,
network creation?
Is this one, good catch. So I'm gonna run this. And did it work? I think it didn't work.
Yeah, it might be because of the change in the layer name. You might have a
Yeah, exactly.
break up front.
So yeah, that's exactly what is happening, right? And actually, I just needed the UT.
Yeah.
So, I forgot the last quotation mark here. Yeah, okay. Sorry about that. Okay, so you can see here graphically how it changed from before, right? And if we go into Project Explorer, if I select my pipe network, yay, I have it here. So the only problem is if you see the elevation, right, is in 0. So this is actually where the other user actually stopped, right? We have a pipe network with our ridiculously big pipes compared to the structures. But yeah, this is what happens when you choose the first part, right? So I'm gonna go a little bit quick here. As I say, I'm gonna share all of this content afterwards, but I just want to show here how to get them into the correct position, right? So I know we have a couple of minutes still left. So here I'm just getting the pipe networks that I created, right? And filtering to get the first one. So I'm just going to do this demo for the first one, UT1. And basically what I'm doing is getting all the pipes and structures, and I'm using some really cool nodes that are in the Civil3D toolkit, right? It's in the API, but basically I'm getting the start point and end point of my pipes. And then I have this node that is surface elevation by XY. I think this one comes actually from the out of the box, right? Elevation by XY. So basically I'm getting the XY and I'm saying, okay, what is the elevation of my surface, right? This is normally what you will do yeah, if you reference in your surface, you can avoid that, right? But I'm getting it directly the point there. One thing to mention around the pipes is that when you reference a surface, you're only checking on the start and the end point. Whereas in pressure pipes, you will be checking the whole pipe, right? Because they are flexible, but it's not the case on gravity networks. So this is what I'm doing here, getting the correct elevation that I'm going to use afterwards. And here I'm just setting the reference surface for the structure. So remember what I said, right? If I change now and set the reference surface for a pipe, for a pipe network, sorry, all of the parts that are already there, they will not get that change. So this is why I'm doing it for each one of my structures. And so here I'm setting then the rim, so it's automatic to the surface. So this was just to show you two different approaches to doing basically the same thing, right? So here we're using the reference surface. Here we are basically calculating calculating ourselves what is going to be the set value of the pipes, and specifically for the invert, because we have this node in the Civil 3D toolkit to set the invert. So I'm just getting some properties also from the pipe, so the outer diameter and the inner height to figure that out, and using that 2.5 feet value that the user said in the forum problem, because they apply a constant value there. And at the end, I'm just demonstrating how to work with the sump also to add a little bit of sump into the structures. Right. So
right.
we're gonna
Let's give it a run.
This.
Excited for this.
Okay. So I have some warnings. I'm gonna show them to you, which is totally normal. Because I have some rules applied, right? It says that the rim to some height is really big. But let's see in Project Explorer what this looks like. So remember, I only did the UT demo one, and here is my surface, right? So I have those values there. So if I go here into an isometric view, you will see one of my surfaces really low, pipe networks really low here, right, at 0. And this is my other pipe network there.
Nice.
Yeah, so do we have the time for the next one, or
I think we're out of time. We can look at getting stuff shared out another way if we want, or maybe we'll set up another session in the future to cover the interference.
Yeah.
Cool.
So I'm gonna stop sharing here.
I will take over the share, and assuming I can find Zoom, because of course I can't. All right. So skipping questions in the interest of time. Sol, over to you.
Yep. Alrighty. So very quickly, this was the first part in this 3-part Civil 3D series. So thank you so much, David, for presenting today with us. It was awesome. Next one we're going to look at is where in the world is my Dynamo, focusing on GIS. We're going to have a special guest, Anton Huizinga, and then blocking it out with Zachary Jensen on the 20th of April. That would conclude the Civil 3D series before we jump into Awakening the Dynamo Force on May the 4th be with you, with a mystery special guest that is probably going to be Josh Goldstein, but we haven't actually asked him yet. We're going to talk about working with JSON file formats and transferring things between things. But there's also many awesome things to come later. So please do hang out with us and come check out all of the series every 2 weeks.
All right. Thank you, everybody. This is another great session. Thank you to Jacob, Saul, and David for presenting. We encourage you to join us in the community. I've already thrown a whole bunch of these links into the chat, hopefully give you a little bit of time to copy and paste the ones that are the most interesting to you. And I'll probably also put these on the event page in the comments section, so you'll have them looking forward. One of the links that I added in there also, though, is if you are interested in hosting one of these conversations, I added up there a proposal link where you can submit your ideas for an upcoming session, and then someone from our team will get a hold of you and help you get that set up. So with that, I think we are ready to wrap up, gentlemen. Thank you, everyone, and we'll see you next time.
Bye, everyone.
Thanks, everyone. Have a good one.